안녕하세요, 이승준 연사님.
네, 안녕하세요.
네,
혹시
안녕하세요.
목소리 들리시나요?
슬라이드 공유 테스트 한 번만 부탁드릴게요.
네, 알겠습니다.
안녕하세요. 이성준 씨,
네,
안녕.
안녕하세요.
네, 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 조금 늦게 들어왔습니다. 네. Now it's 9 o'clock, so let's get started. We have a very unusual speaker, probably the youngest uh, speaker in this semester. We have Aidan Lee, Lee Seong-jun, uh, the co-founder and the CTO of 12 Labs. So 12 Labs is, uh, I think, one of the startups, I think, based on San Francisco and Korea, that builds the video foundation models and try to apply to many applications. Now, let's go ahead. Go ahead, please.
Thank you, Professor Chow. And hello, everyone. My name is Aiden. I'm one of the co-founders and CTO at Toll Labs. And as Professor Chow mentioned, I expect I be the youngest speaker here, and I'm very honored to be here to present my founding story to the fellow students at SNU. And my talk, the story that I'm about to tell today is not going to be a research talk. It will cover some of the technical aspect, but I wanted to focus on my, you know, mostly on the founder story itself, and to share a glimpse of what it is to be, outside of academia, and just give a sense of what startup looks like. So, everyone can see my screen, right? Okay, sounds good. Agenda, I'm going to give a quick intro of 12 Labs. I'll also share some of the key technical challenges at 12 Labs in the middle, and founder story, just behind the scene of a founder when we had no money, and conclusion. Yeah, and this is about myself. If you look at my LinkedIn, it's very unconventional. I only have one line of experience. I've co-founded this company. I studied at Brown, doing computer science and applied math. I wasn't able to finish because I started the company during while I was doing my bachelor's degree. My goal was always to be a scientist like you guys, and I planned to originally go to grad school, but I saw this opportunity to to start a company with my founder, with other co-founders, and it's non-traditional. So I'm going to share that story as well in the later part of later part of the presentation. But it's now been more than 5 years that I started the company, and I never knew I was going to do more than 5 years. About 5 years. I always thought it was going to be maybe 2 years or 3 years max when I started the company, by the way. Yeah, and this unusual path led me to do exceptional, career and non-conventional experience at my age. Forbes 30 under 30. That's one of the accomplishment that I achieved as a found. While I led the company. Workshop organization or organizing a workshop on the first video language model workshop in Europe. These competition all were things that I achieved while I was the found while I was a CTO at Toll Labs. Oh, and please feel free to ask questions in the middle if you have any, and I'll also look out for the Zoom chat as well. So about 12 Labs, wanted to give you a quick intro of what 12 Labs do. So 12 Labs is a full stack video understanding of research and product company. So there's lots of keywords here. So I just wanted to dissect it. So we work with videos. We work with lots of videos. So that's one. Research and product company. We do our research. So we're a company that builds our own model and also productionize it. So we're not a lab that's just working on publishing papers. We are not a just a product company that wraps around other models. We do both. So we are a full stack research and product company. And we have office both in San Francisco and Seoul. We're a global company that's working with global partners, where our team members are spread out in the States, in Silicon Valley, and Seoul, here in Seoul. So let me just get everything here. So, 4 things that I want to highlight about 12 Labs. So we work with the leaders in the industry. So these are some of if you look at on the left side of the screen, these are some of the representative customers that we work with. NFL, Paramount, Disney, MLC. These are all companies that we work with. And I just wanted to highlight NFL because it's a multi-billion, NFL is the largest sports league in the world, including World Cup and Olympics. And it's a multi-billion industry that we tackle. We work with because videos is their main asset that they use to generate revenue. We're also backed by leading investors. In Korea, I think we're known by the first startup to be invested by NVIDIA. We have raised $110 million in total. We're a Series A company. We are also supported by various AI luminaries. Just highlight a few here. Along, Aidan Gomez from Cohere. He's one of the authors. Some of you already know, but he's one of the author of the Transformer paper. Fei and Alex, they're all big supporters of 12 Labs. And we are partnering with the best global partners, AWS being the primary partner that we closely work with, and well, to share how we are, and I'm also share how we are partnering with AWS in the later slide. And yeah, so 12 Labs, we have 50+ scientists and engineers that marry video and language. This is our team picture last year. Yeah, I don't know why we only see guys, but we have lots of great, female scientists and engineers after this picture. But yeah, 50+ scientists and engineers. Most of them coming from either video background or language background. Some of the background, they're the winners of global competitions. They published in these venues that you guys probably are already pretty familiar with. And right now we want, because the founders are Korean based, has the Korean identity, we also try to contribute in the Korean AI ecosystem a lot. And we're trying to pioneer the path in the AI system, in the Korean founder AI startup ecosystem, right? So we were the first model provider to be on AWS Bedrock, which there are only 10 companies in the world, including Mistral, Anthropic, Stability AI, that some of you guys already know. We're one of the this article just came out yesterday, I think. We've been selected as a top 100 AI startup in the world for four consecutive years. And as I mentioned earlier, we're the first startup that's been invested by by NVIDIA as a Korean founder-led startup. So what are we trying to solve? So these companies, these media entertainment companies, when you look at their cloud storage, they essentially have this massive archive of videos. Usually, it can be small as 1,000 hours, or it can be as large as millions or billions of hours of videos that are stored in their database. Right now, they're just being stored. So it's not being utilized, it's not being active, it's not being used as data. It's just acting as a storage component that they need to have in case something comes up in the future. And what they really want to do is to interact with this data. So for example, you submit a prompt, show me all the scenes where, someone scores a goal, or tell me key moments that happened on July 4th, 2024. These queries or these prompts, using these prompts or these queries, they want to essentially get an answer out of this, right? Because because once you have these answers, then they can start understanding what's inside the data, and they can think about how to utilize them for whatever their business need, right? But this was not possible until recently, and this is the core problem that we really wanted to solve. Previously, it was usually used by this problem was solved through tags. So for example, you use expert CV models like Google Vision or Azure, these kind of traditional vision models to create tags out of videos, and you store it. But then, once you store them, once you generate these tags, it's actually very hard to actually interact with them, because people don't search, or people don't remember the tags that you created, like, a few months back or a few years back. And they want to use these natural language to actually, the things that just pops into your mind to access or to analyze this video. So tags weren't the solution. Generating tags weren't the solution to tackle video understanding. Then, in 2020, I think everybody knows, new technology paradigm came out. Language being as an interface. GPT-3, I think, it gave a new language interface to text data, and CLIP paper in 2021 gave an interface to image data, right? And our motivation was simple, right? How can we create like a language interface for videos, right? Because there was no language interface for videos that can be useful for these businesses. So, our first, so that's why we we founded 12 labs, and we came up with 2 solutions, right? One is search, essentially doing search with language interface. Just giving a quick demo here. Yeah, sorry, that might be too marketing, too salesy, but yeah. So search was our first language interface that we developed. And the second interface that we developed is a question answering module, right? So essentially taking video as a prompt and a prefix prompt and generate text response tailored to user's prompt, right? For example, generating a summary or generating chapters. And based on this extracted information, they can use it for their downstream task, right? Yeah. So these are the 2 solutions that we developed at 12 Labs. We're developing at 12 Labs. And yeah, and I want to kind of introduce what's really challenging about video understanding and how it's different. Move on to the conversation. What's some of the technical challenges that we had to overcome and face to make this to develop this product. Any questions so far? Sorry, I think I've been speaking for the first 15 minutes straight.
I think it's okay.
Okay, sounds good. Thank you. So for some of you who are familiar with video understanding, this may be obvious, but for those who are not familiar, I want to introduce what makes video understanding so challenging apart from other data. So first of all, let me just play this. Yeah. So this is sun setting, this is sun rising, right? And unlike images where a single static, unlike images that doesn't have temporal aspect of the data, temporal aspect, video has this temporal aspect, right? So this is exactly the same video. I just rewinded the first video and put it in the second video. And apparently, if you ask this video, if you upload this video to even the most state-of-the-art video language model, they still get confused, right? So temporal aspect is the first axis that makes video understanding so challenging. This one, let me just play it. Now, assuming we have a different music, attached to the video, the feeling that you get from the video is completely different, right? The video on the left gives you, this feeling, a sad feeling, a sorrow moment, looking at the sunset. The right video gives you the feeling of, something like a party feeling, excitement, even if the visual content stay the same, right? So the second part that's making it challenging is the audio understanding, right? Video is not only a visual data, it also has that audio component that needs to be incorporated with the visual data to have that full understanding. And the third part is the alignment between video and language, right? Video is a continuous data, audio-visual data, but the prompts that you're asking or the interface, the language interface that you're interacting is a discrete data, where there is that clear modality gap between the two that we need to make it align to, right? So aligning these two data, I would say, is a third challenge that video understanding uniquely has. And going on to some of the engineering challenge here, apart from the modeling part, if you look at this, this is a screenshot from AWS H100 instances, their info, the spec of the H100 instance in AWS. And if you look at the storage component, it has 3.84 terabytes storage attached to this instance, right? That means each node has a local storage of roughly around 32 terabytes. And one of the reasons why this becomes an issue is for videos, the typical data size is about 150x than text, right? For doing training text models like Llama 3.1, you can essentially put in all the data. 9 trillion tokens is roughly 32 terabytes. You can put all those tokens in a single node, and each node can grab these data locally and use that for training. And train it on real time, right? But for videos, for 50 million hours of video, that's roughly 5 petabytes of video files. You can't put that into single storage, right? Single node storage. So you have to have a different training infrastructure to train these video understanding models, and that becomes that fourth engineering challenge, fourth challenge, which is mostly engineering component. So one is temporal understanding. Second is audio understanding. 3 is the modality gap between text and video. And 4th is this new infrastructure, training infrastructure that you need to train these large-scale video understanding models. And yeah, and my next section is about solving this, right? What 12 Labs did to solve this, with going over how we train our Marengo model, which is our video native any-to-any retrieval model, and yeah, just share some insights from that. So again, recap: our Marengo model is an embedding model that enables semantic search. So you take in text. You take in text prompt from the user, and we have video embeddings that are stored in our vector database, and we perform similar research, right? And the model that's turning these text and videos into embeddings is our Marengo model, right? And if you're familiar with CLIP, I'm pretty sure folks who are familiar with CLIP could right away kind of make that similar analogy, right? So quick recap of CLIP. CLIP takes in text, which embeds into an embedding using this text encoder. It also encodes image into embedding using an image encoder. And it's trained on large-scale image text pairs with contrastive loss objective, right? So it maximizes the similarity between positive image text pairs and minimize the similarity between the negative image text pairs. And so CLIP is trained in this way, and it works surprisingly well, not on like classic classification tasks, but also in retrieval tasks, right? So our goal is to basically train a video version of CLIP, right? How can we create a video native CLIP that enables semantic search across videos? So the first challenge is to think about the data, right? CLIP is based on image text pairs. Now for videos, we need to have video text pairs essentially, right? And things that we need to consider when we built this data set, we had lots of referenced lots of learnings from how to train better CLIP model, right? And one of there are a few factors here. The factor number one obviously will be the scale, right? There's been numerous studies around scaling laws, and scaling laws also apply to image text pairs. So more data, more image text pairs, better performance. But what's also important is the composition of these image text pairs, right? There's a challenge called data comp, helped by Leon organization, where given the same number of data, what will be like? How can we same number of data set and also the compute? Figuring out what the best composition of that data is influences lots of performance, and that's also currently organized as challenge called data comp. So taking from this learning, composition of image text pairs also matters significantly in terms of performance, and also the quality of the text pairs, right? Right. It's one thing to describe a picture in a single sentence, and another to describe it into a very long, paragraph of detailed text, right? So, essentially, scale, composition, and quality of the text description is something that we need to consider to train better multimodal models. Oh, someone I think had a question. Or
I think it's a noise.
okay, sorry, I'll continue. So these were some of the learnings that before we even started to to gather or create this data set for large scale video text data set. We need to consider when creating this data set, right? Quality of text pairs, composition, and also the scale, right? So what we did is we acquired bunch of video text pairs, both publicly and privately. So that's the data acquisition there. So that's the scale part, right? We need to collect very, very large scale of video text pairs that are available on web and from the companies. We need to filter it to make a good composition of these video text pairs. So there's a second stage of data filtering there, where we filtered into 100 million of video text pairs in total, and we augmented these 100 million video text pairs through recaptioning, right? So increasing the quality of the text data, right? Because usually these text data that's collected from web or privately are very they're usually very noisy and concise. So we wanted to make sure we caption it to have a very solid description, detailed description attached to these videos, right? So essentially acquisition, filtering, augmentation, 3 layers we went through to have this a very large scale, high quality video text pairs. And in addition to these video text pairs, we used, we also went through the same process for images and audio text pairs to have this collective collection of a multimodal data set that we can use for training. So 100 million video text pairs, 500 million image text pairs, and 500K audio text pairs ready to be used for training our video link body model. So that was the data layer, right? Now looking at the model layer, right? Text encoder, assuming we want to interact with text data, that should be fine. But image encoder is something that we need to change, because image encoder does not have temporal understanding, and it also does not have audio understanding, which we saw were the inherent nature of the video, right? So we need to come up with a new model architecture to capture these 2 aspects. And this is the architecture that we came up with, right? So essentially it's composed of 3 components, right? First is a vision encoder that can take in multiple frames and map the temporal relationship between the frames versus like traditional single frame vision encoder. We also have an audio encoder that captures both non-speech and speech semantics. So these audio expert encoder model creates an embedding from the audio that's extracted from the video. And fusion model that can fuse these 2 modalities together to come up with the final audio visual representation of that video, right? And I don't have a specific the specific architecture is in our blog, but these are all transformer based, and the details actually when we experimented didn't really matter. Some of the hyperparameters, tuning, we've done several tuning there, but what really mattered is the high level, I would say, structure of this component and the quality of the data. So this is one of the reasons I'm not going too deep in the architecture itself, but mostly on the structure. And once we have this model, it's a training layer, right? So we change the data from image text pairs to video text pairs. We change the image encoder to video encoder, and then we train it on this contrastive loss objective to align these 2 models together, right? And one of the key requirements here is compute, because we need to have a very large batch size to make sure we have a this contrastive learning objective is also dependent on the batch size. We need to have this very large number of GPUs to do that, to handle that. And our model is trained on few hundreds of H100s in a distributed training manner. And as a result, we were able to achieve pretty good performance. We have performed most of the stated, if not all of the state-of-the-art results in different benchmarks. And it's currently now in our service where people can play around, right? So handling queries like Spider-Man flies through a street and catches a car with his web. You can also put in image as a query to find things. Here we uploaded, a customer uploaded a logo of Molten, and we were able to find the moments where these logos appear, and then they can use this information to, for example, do contextual advertising or come up with a new video based on these search results and whatnot. So that was our Marengo model. That was our embedding model. And we also, the second model we have is Pegasus model, which is the video language model, right? That can do question answering. And again, the goal of this model was to come up with a model that can extract information from videos in text. So that can be summary, or that can be chapters or highlights. And when we started the company a long time ago, like back in 2023, it doesn't feel, it's only been 2 years, but it feels very, very long. If you think about the history again of ChatGPT, ChatGPT came out in November 2022. The first version of Llama 1 came out in February 2023, and Lava model, if some of you are familiar, a first open source vision language model came out in April 2023, right? And in 2023, essentially, there was no industry standard video language model that people can use, although there was a strong need for it. And that was the motivation for our company to start building this model, and release it to the public, for the downstream use cases, right? And again, when we released it, there were, we only had previously the embedding model that's only able to do semantic search. But we essentially now wanted to take that semantic search embedding layer to the language space again for people to use it for language specific downstream task. Going to the model architecture a little bit. Quick background update again, just like Clip, right? I think usually the pattern is there's a language, there's vision language model, and then there's video language model. And just before video language model coming out, if you look at the Lava paper, which is the vision language model or image language model, it has 3 components, right? There's the vision encoder, there's a projection layer, and then there's a language model, right? And this projection layer essentially is almost like a tokenizer that turns visual encoders output into language understandable tokens, right? And when we looked at this architecture back then, this is the part where we really wanted to focus on, right? Language model part is the same, we still interact with the language, but the input to that language model needed to change because now we want to input not only images, but also not only image, but also videos, right? And again, that's the motivation of our model architecture here. We changed the vision encoder to video encoder that can take in multiple frames of videos and multiple frames of image, multiple frames and also audio. And we trained a separate tokenizer that can translate these encoder features into language-specific features, and that can now be understood by the language model, right? And the training data as well, right? We also need to change from image text instruction pairs into video text instruction pairs, and align that together through end-to-end training. But this is still an unsolved problem. Long video understanding, because the number of tokens, language model has the limitation in the context length. There is finite number of video tokens that you can put in, and because of that, long video understanding is still a major challenge in this field, right? If you look at our model, we take in 1 hour max of video. I think Gemini also takes in 1 hour max. But typically the users or the industry, the video's length can vary from 2 hours to 5 hours or even more. And this is something that we are also still actively researching within the team. So after training the model, some of the quality results here. Now people are able to ask questions like at what time in the video did the scoring first appear in a football game? Or more complex questions like how long does it take for there to be the first touchdown, right? And the model will respond almost like an assistant, someone who watched the video and give you that information back. So going back to the original problem, right? What are we trying to solve, right? We want, given this video database, say it's 1,000 hours, millions of hours, the user wants to put in a prompt, right? To get whatever information they want from this archive, right? Show me all the scenes where someone scores a goal. Then, we want to have this system where the model or the system can essentially give that answer. And we believe those two models of search, you are able to go through all these archive of videos and then perform question answering on top of the search results, the return results, search results, can enable this workflow for the enterprise, for the customers. So some of the customer highlights, we have MLSE, who's a customer that utilized our product. They are owner of six teams, and including NBA, NHL, MLB, where they have thousands of footage, I think, generated every game. And they're using our model, our system, to quickly create highlights. We're also working with public safety companies, including the government, where they want to essentially generate reports from video footage or detect anomalies that are happening in the security footages. So yeah, that's essentially it for our technical challenge. Any questions so far? I'm moving into a different section. It's more on the founder story. So I wanted to make sure I give time to ask questions if there are any. Okay. Okay, I will move on to the founder story a little bit. So this is a completely different theme that I prepared for this seminar. And I want to just share, sorry, I saw a question. What is the main difference between enlarging text token length and video token length? So text token length is about the prompt length, right? So it's about how complex text prompt that you want to put in. So for example, it's one thing to ask the model to summarize, like give the model a prompt like summarize the video. But if you want to be really detailed, you may want to expand that prompt, right? So putting in more detailed prompt will be able to put in more detailed prompt will be related to the text token length. Video token length is more related to the duration of the video. So if you want to the longer the video, it will need to create bigger number of video tokens to capture all those information, and that's being limited by the context length of the language model. So I'm not sure if that answered if that was your question, but yeah.
Hi. I was Yeonjun who was questioning on through chat. What I really want to ask is, what is the methodological difference between enlarging text token and video tokens?
In this video language model setting or in the embedding setting?
In the video language model setting.
Yeah, so essentially we want to, so I think the goal here is we want to increase the context length of language model, right? So assuming that we have fixed number of fixed video tokens or text tokens, if we have a larger context length of language model, then we can take in longer duration of videos, right? Assuming that video tokens and text tokens, they're proportionate to the duration of the video, right? But if the language model context length is fixed or is confined to a certain number, then what we want to do is to reduce the number of video tokens that's created from the video tokenizer, right? So that's one of the core research topic that our team is working on, right? Because that means each token will have higher density of information and requiring less compute for the language model to handle longer video. Does that answer your question, Yunjun?
Okay, thank you.
Okay. I think I have a question from Yubin. How is the data stored, especially at the client level? Do the clients entrust 12 Labs with their data, or is the model applied on top of client storage somehow? Yes, so that's a very good question. So usually the enterprises that we work with, they don't want to send their data to us, right? Because whether it's because of the IP issue or any legal or privacy issue, they don't want to send it out. So what we do is we deploy our models in their cloud VPC or cloud network, right? Or we also the reason why we partner with cloud vendors like AWS is because when we upload our model to these cloud vendor, then the cloud vendor can be in the middleman where they can essentially provision our model into our client's data center or VPC, and that way the data never has to go out of their original data storage, right? So that's in the cloud setting. But for clients that have their own data center or on-prem kind of environment, we also provide packages that can be installed in on-prem. And that's possible because we train our own model and able to package that model into a system that can be deployed in the setting.
That makes sense. Thank you.
Okay. Okay. Now moving on to the founder story. Yeah, this is I just wanted to share some of the behind the scene of being a founder of a startup to just give you the glimpse of what it looks like. So our co-founders, so we met in the military. This is us building a demo when we were in the military leave. We went to a special military unit called Korea Cyber Operations Command. And most of the team members there were engineers, software engineers, and scientists who either worked in this industry or who just graduated from grad school, right? And that's where we met. That's where our co-founders met, and we literally slept in the same barack, and ate together for 2 years. And that's when we knew we may be able to do something cool when we get honorably discharged, right? And in the early days, of course, we had no money, right? When you come out of the military, you don't have any money, and so when we worked on a project, we had to drink coffee, and because we had no money, we drank coffee from like gas station store, right? This was actually the gas station store picture that we took back in the days, where we essentially bought our coffee and food in the early days. And but you know, why we were doing, why did we do this, right? What made us to decide to build a startup, right? Well, in 2020, we knew two things for sure. We had a very strong sense of mission. First, even before AI, there were text analysis tools, right? Elastic, Splunk, these are all text analytics tool, keyword-based search engine. But there were no developer tool for videos, right? And we thought that was a big problem because 80% of the data in the world is in videos. And second trend that we saw was GPT-3, right? You know, in 2020, I think people were doubtful. There were I think lots of doubters who didn't think language model is going to be a thing. There were lots of articles around it. But you know, at least our founders, we had this belief that a language model will conquer the text data. So so if that happens in the next 2 to 3 years in 2020, next data to be conquered should be videos. And these trends we knew for sure, these two like things that we knew for sure, and we wanted to start a company that address these two status, right? So we built a demo and we applied to an accelerator. It's called, you know, I'm not sure if anyone is familiar with Y Combinator. We didn't go to Y Combinator, but there's a Y Combinator equivalent types of accelerator in the States called Techstars. And we went to this Techstars Seattle program, and at that time we had no product. We just had a demo, right? And we're lucky enough to get in, but there was a problem. First, it's a Seattle. It was a Seattle program, so we were in Seoul, so we had to fly over to Seattle, right? But you know, COVID hit, COVID-19 hit, so no one was able to go to the States. You know, we were all stuck in Seoul, and had to figure out how to participate, right? So what we did is we switched time zone and joined from Seoul. And our day essentially started at 2 a.m. And ended at 4 p.m. So we essentially switched our time zone to accommodate the schedule to participate in the program on the left, and everything was virtual, right? On the left, you know, you can see a screenshot of all these founders and you know, managing director helping us out and you know, discussing different things. On the right, you know, you have that classic pizza in the night to kind of work together and quickly iterate. And you know, this was way before ChatGPT in 2022. Again, this was in 2021. One of the common questions that I got was, you know, is your technology better than Google's or Microsoft, right? And I guess like for anyone who's trying to build a deep tech startup will face this question. You know, is your technology better than this big tech or this company? And this is a common question that, you know, you just cannot avoid. And we also face this, right? Especially because our founders were also a first-time founder and didn't have that academic pedigree, unlike other deep tech startup founders. So, you know, we decided to participate in a global challenge, and to prove that we can be competitive. And you know, we were lucky enough to win the first place in this video retrieval track video search competition held by Microsoft in 2021. And I think a little bit a story behind this is that we only had 8 people, right? And 8 people at this time, they need to do like they need to build a product, they need to do their regular business, and we need to find the time to allocate to participate in this challenge. And that required huge decision making from the team to make sure we have we give time for people to really work on this hard, right? Apart from the actual business and product, right? But we felt that this is necessary at the time, and we were lucky enough to win the competition together. And this eventually led us to this seed round, 5 million seed round from the Silicon Valley VC in 2022, and really gave us that credibility to the founding team that we may be able to build something big together, right? And this is a picture that I took when we flew over to 22. That's Professor Fei Ali and one of our partner at VC, and kind of like shared our story that we want to really bring Korean talent to the global scene, global AI ecosystem, and be that connector, be that bridge essentially, right? And Fei also, she also knew lots of Korean students or Korean scientists that were great, and saw that vision together and help us build that journey together from then, right? And fast forward to today. Now we're about 80 people. We are five people company in 2020. We're now 80 people in total. Offices in both San Francisco and Seoul, where we all have this sense of mission to build the best video understanding model and product, so that these enterprises can leverage their data that's stored in their archive together, right? So it's most people believe we were funded well in the beginning. That's not true. We started from the gas station coffee, and worked really, really humbly and hard together as a team to get to this point together, and still grinding hard to provide better product to our customers, right? And yeah, now recently we were able to be on Bedrock, AWS Bedrock, which is pretty along with top global companies like Mistral and Anthropic and whatnot. And yeah, so some of the learnings as a founder versus when I was a student. Being founder, it's not about being ready. It's about doing with a great team. I couldn't have done this without a great team. If I have thought this through, I wouldn't be able to execute. It's mostly about doing what needs to happen right now with a great team who has who has the same view on the mission and commitment. I also learned to be very humble. If you do a startup, you learn that there's always someone smarter and richer than you, and that's something that people can have the perspective, but like when you actually feel it, you really, really do become humble and always try to learn from others, and be motivated to become a better person overall. This is something that because I'm in the AI industry, I work closely in the AI industry, that I see often. Lots of breakthrough, I think, comes from these 5 factors: your intuition, engineering, math, with compute and data. Compute and data, I think, is mostly coming from the company or the environment that you're working on. But as an individual, an individual scientist and engineer in our company, each of us try to be good at least. Try to be good at least 2 of the 3, right? You either really have a good intuition and engineering, or you really have good intuition or math, or really have good at engineering and math, right? In the foundation model era, because that's what really matters. when you start to work with large models and apply to many downstream use cases. And yeah, and we're also hiring. So whoever who are interested in seeing your research turn into product and have global level impact, please apply. We're actively hiring at all levels. Thank you. That is my
Yeah.
question.
Well, thank you very much. This is very inspiring talk. Especially you're young, in the 20s or late 20s, or still you're learning and you're building product. And actually, you know, the degree doesn't matter even if you didn't finish your bachelor yet. You know, what is more important to you, your knowledge, and your knowledge is growing. Okay. Any questions?
안녕하십니까. 혹시 소리 들리시나요?
지금
아, 네.
얼굴이 안 보여요.
아, 네.
어.
네, 저는 서울대학교 데이터 사이언스 대학원 박사과정 2년차 심주 전사들입니다. 두 가지 정도 짧게 질문 드리고 싶은 게 있는데, 첫 번째로는 혹시 이 소개해 주신 그 시스템에서 레그나 벡터 DB와 관련된
지도 교수가 누구예요?
네, 저는 이상원 교수님 랩실에 있습니다. 네, 그래서 소개해 주신 시스템에서
데이터베이스. 예.
네네, 레그 혹은 벡터 DB 관련된 이슈가 혹시 있으셨는지 궁금하고요. 두 번째로는 혹시 이거를 인퍼런스 할 때, 한 개에 대해서 인퍼런스 할 때 GPU 컴퓨테이션이 어느 정도 사용되는지 좀 궁금해서 여쭤보고 싶었습니다.
Maybe we want to translate it to English because there's a audience who don't understand Korean.
Okay, so I think the first question was around was there any technical issues or difficulties around the database and a vector database or RAG? I guess that was the first question, and the second question was what's our hardware requirement for doing inference? Okay. Yeah, so the first question, vector database, that's a really good question. Honestly, our view is that there is no good vector database solution out there. So we mostly have to configure our own and actually make it work for our system. So going back to your question, there are difficulties around vector databases. We work with all the vector databases, so Pinecone, VV8, Quadrant, Milvus. They're all of our partners that we work with. But we do have our own set of database operations that we optimize to overcome some of the limitations of these databases. One thing though is that apart from the technical limitation, our customers usually have their preferred partners. So for example, NFL, they might have already partnered with Pinecone. Then we actually have no choice to work with Pinecone and store our embeddings there. So we try to make sure our API interface is flexible to different types of vector database and and adjust to whatever environment that we need to deploy. Regarding the inference part, yes, it's a challenge. So our model is, I wouldn't say our model is as large as GPT-4o or Gemini Pro type of models, but it does require multiple nodes of H100s to run inference. And one of our core tasks of our ML engineering team is to develop that inference system that's specialized for video language model, right? And that includes decoding the videos, running the model, and also provisioning these hardwares as well. So yeah, going back to your question, few nodes, multiple nodes of H100s.
네, 감사합니다.
Any other questions? Feel free to ask.
네, 안녕하세요. 저는 협동과정 인공지능 전공에서 황성훈 교수님 연구실에서 연구하고 있는 박사과정 3년차 정연준입니다. 아까 질문을 드렸었는데 좀 더 궁금한 게 있어서 질문 드리고 싶은데요. 그 LLM이 약간 챗GPT에서도 이머전트 어빌리티 텍스트를 막 많이 학습해서 이머전트 어빌리티를 많이 얻었다는 얘기가 있었는데 비디오 랭귀지 모델에서도 그 비디오 랭귀지 모델이 이제 LLM과 텍스트만 학습한 LLM과 비교했을 때 어떤 이머전트 어빌리티를 좀 얻는 거를 그 보시는지 조금 궁금합니다.
Okay. So the question is, in LLM world, there's been phenomenon called emerging capabilities, when going over certain scale, and have we seen anything similar type of emerging capabilities when we train video language models? Yes, I think we have seen that in certain scales, and that's related to that's what we call as we call it as video reasoning capabilities. And video reasoning capabilities for us are about like, essentially chain of thought for video language model task, right? So it's one thing to answer question answering directly for videos, like, let's say, one thing to answer it, like, say the prompt is how many people appeared in this video, right? One way to answer it is just straight out say that number, right? But the other is to come up with that chain of thoughts, right? Of how to get that to that 5 people, right? You could be, asking internal iterative questions to yourself, to the model itself, right? First look at the frame on number 1, let's look at frame number 3. And then, like, summing up all these numbers together to come up with the final answer, right? So we've seen that certain video reasoning capabilities coming out once it goes over a certain scale, both in terms of the model parameters and data.
Thank you.
Any other questions you can ask about, how to start startups? There's a question here.
I think I think I got something in the chat.
Yeah.
So the first question is, to deploy a multimodal model and small devices like smart glasses, it needs to be lightweight. Does 12 Labs offer service only in the form of APIs, or are there pre-trained models available for on-device use? That's a very good question. We don't currently have publicly released on-device models, but that's something that we are internally developing. And I'm working closely with some of the hardware companies together. I would want to ask why you asked this question, if you're interested in doing an on-device model. But yes, that's something that we are developing internally. The second question is, videos typically consist of 30 to 60 frames per second, leading to high similarity between frames, making it inefficient to embed every frame. Do you use a specific sampling method, such as embedding only keyframes? Could you please explain more about your frame sampling approach? I would love to talk about this, and this is a very, very good question. Unfortunately, I cannot go into the details of the methodology here. But I can say that it is a very important research topic that we address within 12 Labs. From SJ, I am a PhD student. There will be big challenges due to rapid growth for a short period of time. I wonder what was the biggest challenge for a young CTO to manage many and ever-growing technical members, and how to overcome it. Wow, that's a very good question. So my biggest challenge as a CTO, by the way, at least within our company, age doesn't matter. So we don't think, there are people that are younger than me who's better at coding and better at science than people who are much more older than me, and senior than me. So age really doesn't matter in our cult in our company. But as a CTO, some of the challenge, most of the challenge came from people management. I think it's one thing to come up with a structure to make 20 people work together or 10 people work together. It's another to come up with a structure of 50 people working together, because now the layer becomes, there could be multiple layers within the team, right? 20 people company, everyone, I know everyone. I can always chat with all these 19 people. I can have lunch with them. And there's no real hierarchy in between, right? Once you hit 50 to 100 people, there are managers, right? There are managers of ICs, and I have to mainly work with the managers to make sure people are aligned and people are also happy, right? And people feel that they're growing, right? So realizing that has been a challenge for me, because I also wanted to grow myself. I also had that growth mind. I also wanted to grow as an individual contributor. But later in the stage, I realized that I had to be the person who, like, the biggest person in the company that that facilitates the growth of our technical members, and come up with a good structure and culture for that, right? So switching that mindset has been the biggest challenge, if I were to answer your question. Yeah, and there are like other small challenges, like how to make cross-functional team work, right? Scientists think very differently than engineers, right? Engineers, there are people, if you're an engineer persona, you're a person who doesn't like uncertainty, right? You want to make sure that everything works and everything can be scalable, right? If you're a scientist, you thrive in uncertainty, right? You want to work with unsolved challenge, and you want to see the possibility of making things work, right? And although they all work with, they all speak like coding and they do coding, like, because of that mindset difference, it's not an easy thing to do, to create a culture environment where both can collaborate together. So that, I think that's another axis that I think has been one of the biggest challenge that I faced in building this foundation model company, right? If you're all engineer, then it's people speak the same language. If you're a scientist, you're an engineer, you're a product, they speak different language, and you have to make sure, you have to be very intentional about making them work together.
I have a question. I think you had a slide on the skills that you need: intuition and engineering, around math with computer and data. So I think the later part, we know that's something that we get from the education, intuition and engineering, and also probably the domain knowledge, would be very important for solving real problems with the customers. And you're dealing with the sports video, and I think you're also dealing with the the city monitoring, and these are quite different, right?
Right.
So how many people, how many domain experts you have, and what is your plan for acquiring this kind of talent, or maybe collaborating with the other companies, like I think I probably mentioned in San Francisco that there's a company called bPro11, specialized in real-time video analytics of sports.
Yeah, thank you. That's a very, very good question. So I'll break my answer into two parts. About our company and why I
Mhm.
didn't put in domain understanding in this bullet point. Industry experts, we have about, so for each industry we have about 3 to 4 experts that have been working in this industry for a very, very long time, something like more than 15 to 20 years. And those team members are mostly in the go-to-market team, our business unit. And the way we work is that these go-to-market team, these domain experts in each industry from the go-to-market team shares their prompts or shares their insights with our research team or with our product team, that this prompt is going to be a killer feature because of XYZ reason. And this could be a differentiator. Like they actually pitch internally within the company that this should be the core capability that our model should be able to do. And that's how we kind of acquire domain knowledge, right? These go-to-market people, they always talk with the customers, they know what the customers are looking for, and the process is that they try to pitch that internally to our researchers, engineers, so that those domain knowledge can be incorporated in model building, right? And also they also tend to contribute in constructing the evaluation data set for these domain knowledge specific data, specific use cases, because usually we don't have those evaluation data set that the research can work with. So these domain knowledge experts contribute in that front. They pitch, they also help with constructing the evaluation data set.
Mhm.
And we have about 3 people per industry that helps that front. Yeah. And
Okay, yeah, go ahead, yeah.
and the second part, the reason I didn't put domain knowledge here is that I think with these 3, as an IC, I think you can, individual contributor, you can quickly catch up the domain knowledge from others. But here, I was
Mhm.
more specific to potentially the graduate students who are looking for a new job in the industry when they come out, or in the academia.
Mhm. Yeah, okay. So I think I went to the both offices in San Francisco and Seoul. You guys have a very nice office, and it's not like a gas station, but you want to show your current picture of your office. But anyway, how will you attract your employees, your future employee? Do you provide internship to students?
Yes. That's a good, thank you. Thank you for asking that question. So we have internship program. We also hire full-time scientists and engineers. For internship program, it's usually 3 to 6 months where they work closely with our full-time ML scientist on a problem together, or construct work on specific capabilities of our models. But the focus here is not about publishing. Our focus usually is not about publishing like a paper. It's about, you contributing to a model that can be productionized in the real world setting. So yes, we offer that internship both in Seoul and San Francisco, but most of the science team is in Korea, in Seoul. So there could be that natural synergy if you're based in Seoul.
Okay, yeah, I mean, you show the importance of publishing product instead of publishing papers. So, both are publishing, but when you publish a product, well, you also make money, and then you can grow the company. So, anyway, well, thank you very much for your inspiring talk and Q&A, and I'd like to see you sooner or later. Are you in Seoul now?
Oh yes, I'm in Seoul.
Yeah. Maybe we can catch up, sometime late this week or maybe next week. Yeah.
I would love to.
Yeah.
Thank you so much, everyone, for listening in, and I hope, I hope you have a great week.
Thank you. Thank you. Bye.
Bye bye.